Hi everyone, it's Ms. Chow, and I'm just welcoming you to this 6.6 video, which the topic is applications of linear equations. And what you see on your screen right now is sort of what I've solved, but I'm going to go back. I had to come in at the end and redo this piece. So I hope you enjoy the video. Okay, so the first problem I'd like to start out with is a bit of review, just to make sure we're comfortable with all the ideas and applications. So in this case, we have minus 2. I can't get rid of that. Let's see. Minus 2 times 4a minus 7 is greater than 2a minus 6. So the first thing we want to do is to distribute the minus 2 to the 4a and to the minus 7. So minus 2 times 4 is minus 8a, and minus 7 times minus 2 is a plus 14. So now that's been distributed, and that's greater than 2a minus 6. So if I subtract 2a from both sides, minus 2a, just to clean that up a little bit. So that's minus 10a plus 14 is greater than minus 6. So, well, now what do? We can say, all right, so minus 14 from both sides. So if I write this again, minus 10a plus 14 is greater than minus 6. So then if we subtract 14 from both sides, minus 14, and that gives us minus 10a, and the plus 14 and the minus 14 cancel each other out. Minus 10a is greater than minus 6 minus 14 is minus 20. So then we have to divide by negative 10, or you could say multiply by negative 1 over 10. But in any case, we do that. That cancels out. This becomes a positive because minus 20 over minus 10 is positive 2. And what happens to our sign? Well, because we're multiplying by a negative number, the sign changes direction. So it becomes a on this side, and it becomes less than, and on this side is 2. Okay, so so let's give it a green line here. So I always like to put the number on the graph first, just to see where I am. So a is less than 2. Well, less than means that it doesn't include that number. And so therefore you get a hollow circle. And then it goes down like that. Okay, let's try another one here. So negative 3y minus 1 is greater than 20. Well, why don't we add 1 to both sides? So then you have minus 3y is greater than or equal to 21. So, and then we divide by minus 3, or you could say, instead of dividing by minus 3, that we're multiplying by negative 1/3. But in this case, minus 3, so then what does that mean? So that goes away, and that means that y, and we flip the sign, so it's less than or equal to 21 over minus 3, which is minus 7. And so if we graph this one, and we put minus 7 down here, well, we know y is less than or equal to. So there's a big closed dot on the 7, and it goes down that way. Okay, if I were to test this one out, let's say I test 0, just to see if it works. So you have minus 3y, well, minus 3 times 0 minus 1 is greater than or equal to 20. And so that's minus 1 is greater than or equal to 20. Well, that's false. We know that's false, so that's not going to work. But how about if we have minus 8? Minus 8 would be in this category here. So this is x, y is 0, and this is y is minus 8. So we'd have minus 3 times minus 8 minus 1 is greater than or equal to 20. Well, minus 3 times minus 8 is 24, right? Because a minus and a minus is positive. Minus 1 is greater than or equal to 20. And so therefore 23 is greater than or equal to 20, and that's true. Okay, so now we've tested y equals 0, which is outside of this, outside of our answer, our solution. And we've tested y equals negative 8, which is in the set of our solution. And we see that this is, in fact, the solution, according to those 2 points. So the next one is x over 3 equals minus 7. X over 3 equals minus 7 plus 4. Well, let's do this and multiply the whole thing by 3, or 3 over 1, because that will get the 3 out of the denominator. So if you have x equals, well, we could have added these together, but since we didn't, let's just do this. So minus 21 plus 12. And so x equals minus 9. And that's our answer. I have a sneaking suspicion I forgot an x there someplace. But in any case, x is minus 9 makes this true. And this is an equal sign. So we don't have to worry about negatives or swapping signs and all that kind of thing, because the equal sign is the equal sign. Okay, here's the next one, another chance to work with these signs. So if we have this, and we look at the denominators, and we wanted to come up with the least common multiple of the denominators. Well, 2 and 3 would be 6, 2 and 5 would be 10, 3 and 5 would be 15. So it looks like we can't come up with anything less than the multiplication of the 3 terms together. So 5 times 3 is 15, times 2 is 30. So we're going to multiply by 30. And so if we do that, and then we spread that across all 3 terms, so 4 over 5 times 30 minus x over 3 times 30 equals x over 2 times 30. So in this case, so this is 6 and 1, so this is 24. Minus, okay, and this would be 3 and 30, this is 10, minus 10x equals, this is 15, equals 15x. Well, let's see, let's add 10 to both sides, 10x, pardon me, plus 10x. So then it's 24 equals 25x. And that would be, so 24 equals 25x. You divide both sides by 25. And that gives you 24 25ths equals x. Wow, that's quite a number, isn't it? Okay. All right, the next one we're going to do, Okay, the next one we have here is 2x minus 5 times x plus 3 equals 14. So the first thing we want to do is multiply the 5 through, or distribute the 5 through to both terms. So we would have 2x minus 5x minus, because it's minus 5 times positive 3 is minus 15 equals 14. So then what do we have? We have 2x minus 5x, so that's minus 3x minus 15 equals 14. And so that's minus 3x equals 29. And so if you divide by minus 3, that gives you with x. Now since it's an equal sign, there's nothing to change from greater than to less than. It's just as we divide by a negative number, it still stays equal. So that would be x equals negative 29 over 3. And that's your number. Okay. The next one is solve and graph. So 1, I'm going to change colors because I want to. 1 minus x over 2 is less than or equal to 3 over 4. Well, I'm going to multiply this to get rid of the fractions. So I'm going to multiply it by 8. So then it's 8 minus, well, 8 over 2 is 4, so it's 4x. And that's less than or equal to, well, 8 times 3/4, it's 24/4, so that's 6. Does that make sense? So 1 times 8 is 8 minus 8x over 2, and this becomes 4x, and then is less than or equal to 3/4 times 8. Times 8. Well, this is 2 and this is 1, and so that's 6. Okay, so when we bring all of that down here, and then what do we have? Well, we can take minus 8 and minus 8, and then we have minus 4x is less than or equal to minus 2. And so we want to divide by minus 4 and minus 4. And so then we have these go away, and this becomes 1/2. But what happens to this right here? This becomes greater than or equal to, because we have multiplied by a negative number. So this is x, and this is 1/2. What I've done is I've actually set up the graph for you because it's kind of tedious for me to get it all together, and I don't want to do that part of this with you listening, so I decided to just pre-populate the graph. But what I'll do is I'll walk you through the setup of the equations and everything. So first I want to talk about interpolation. Interpolate means to estimate a value between two known values. So suppose we know this value and this value, and we don't know this value here. But we could find it because we could maybe draw a line between these two values and then figure out what the value is in between the 2 points. Extrapolation is different. Suppose we have these 2 points and we want to know a point out here. So what you could do is you could say, okay, I'm going to continue this line, and I bet, based on the information I know from the first 2 points, that the last point is right there, and that's good. So interpolation is in between 2 points. Extrapolation goes beyond the points that you have. So I'll show you how that works in practice. So here we have an example. A 5-minute call costs 40 cents. 5-minute call costs 40 cents. 0.40. And I'm just going to make that kind of a point, right? And a 10-minute call costs 80 cents. So then it says plot the points and graph. So you know you have 5 and 40 cents and 10 and 80 cents. So if you look at the picture here, I did 5, 2, 4, 5. 5 and 40 cents is right there. And so that point is right there. And then 10 and 80 cents, well, that is right there. Because over here is 80 cents. 80 cents. That's 20 cents. And then this here is 40 cents. So we know that these 2 points are on the line, or on the graph. So what I did was I made a line through these 2 points to represent this relationship. So, but then since I can draw a line through these 2 points, the first question it asks is find the cost for talking, for 7 minutes of talking. Well, so then all I have to do is go back down here to 7, and the cost for 7 minutes of talking, 6. 2, 4, 6. It's 6. No, it's 8. No, it's 6. So for 7 minutes of talking, it's 60 cents. So 7 minutes is 60 cents. Oh, 60. So it's like that. And then it says, okay, well, if that's for 7 minutes of talking, what do you think? Extrapolate to find the cost for 17 minutes of talking. So here again, we just keep going out on our line. So let's see, this is 17 minutes of talking. And what does that equal? So here, let's see, 2, 4, 6, 8, 10, 12, 13. So it's $1.30. 17 minutes of talking is $1.30. And we could figure that out based on the line that we were able to draw between the 2 original points, between the 5 minutes at 40 cents and 10 minutes at 80 cents. Okay. The next one is, okay, we're going to look at this athlete. The athlete is training for a marathon and begins his normal practice in the evening. So he leaves his home and starts to run at 6 o'clock. And 7:30, the athlete finishes the run at home and has run a total of 7.5 miles. So basically he's gone around in a big circle. And the circle is 7.5 kilometers. So how fast was his average speed over the course of the run? Well, you could say, let's see, if he starts out and he hasn't run any distance and it hasn't been any elapsed time, then his starting point is 0, 0, which is how I graphed it on the graph. I said, okay, the beginning point is 0, 0. And then he runs 90 minutes and he runs 7.5 kilometers. So if you wanted to figure out his average speed, you could just simply go take the y2 minus y1 and the x2 minus x1 minus 90 minus 0. And then you have 7.5 over 90. And that is your average rate, average speed. And that equals 0.083. 83 repeating. And that's kilometers per second, per minute. So if you actually wanted to multiply this times 1,000, you would get meters. So 1,000 kilometers no, sorry, 1,000 meters equals 1 kilometer. So if you have 0.083 kilometers, and you multiply that by 1,000, well, that's 1, 2, 3. So he runs 83 meters per minute, because these are minutes, 90 minutes. Okay, so now we know this. And you're not here to ask questions, and I know you would, but anyway, let's keep going. So here's our point that we have 1/2 and where's my other point? No, here's my point. Okay, so this is 1.5, so 1.5, so this is 90 minutes. You come up here and 7.5 kilometers, and that's our point right there. Actually, I'm going to make it light blue. So that's the point we know. And this other light blue one, this is another point we know. So if we draw a line through those two light blue dots, we're going to have a line that can represent, on average, this average rate of, or average pace of this marathon runner. Now, so then it says, draw the graph of his time and distance. How many miles did he run in the first 30 minutes? So this is interpolation. So we say, okay, the first 30 minutes, this is a half hour, 30 minutes. And so we come up here and we see that he's run roughly 1, 3, 5, 7, 9. So he's run roughly 3 kilometers in a half an hour. A little bit less. And then it says if he kept running at the same pace, how far would he have run in 3 hours? So that's extrapolation, because our 2 points are down here on the graph. They're not out here. So if he kept running for 3 hours at the same pace, then I've here figured it out. He'll run about 15 kilometers, which is a pretty long way. So finding this point out here, I'm going to use a different color. Finding that point out there is extrapolation. Finding the point in here is interpolation. So this is inside interpolation, inside the 2 dots. Extrapolation, outside of the on the exterior of the 2 dots. Okay, so that's it. The homework is page 235, number 2 to 8, all of them. Okay, and they're all this kind of problem.